Hey everyone, so what we're going to be going over today is basically vertical shift and phase shift. So the first thing that I want you guys to write down, the vertical shift, I want you to write down these two equations, and we're going to write that vertical shift is the amount that a graph moves up or down. Okay, so from there, what I want you guys to do is I want you to take a look at this first example. We're going to add one new concept here while we're at it, and we're going to add the idea of a reflection. So underneath vertical shift, I also want you to write the option of reflection. Okay, just like any other graph, if you multiply the whole thing times a negative, it's going to amount to a reflection across the x-axis. So what I want to start with is I want you to take a look at your graph, and I want you to graph sine like you were going to graph it on a memory quiz. Okay, so here's our sine graph. I want you guys to make one correction before we start. I want you to change this -3, change it to a -1. It's just going to make our graph easier. So what we want to do is we want to try to graph negative sine of x minus 1. So the first thing that I want to do is identify that this -1 right here, it is a vertical shift down 1. So here's how we should start this out. If we have a vertical shift down 1, what that means is that our midline is being shifted down 1. So instead of our midline being on the x-axis, our midline is now going to be at -1. So go ahead and sketch that. Okay, so once we have our new midline, what I want you guys to do is I want you to sketch the original sine graph, and then we're going to deal with that negative at the end. So let's go ahead and sketch a sine graph starting from this new midline, which means sine is now going to start here at the origin, and it has an amplitude, we're assuming, of 1. So we're making the same graph, we're just shifting it down. So in essence, we're going to be at 0, 0, which is now at 0, -1. And then our next point, which was at pi over 2, comma 1, is now going to be at pi over 2, comma 1 minus 1, which is 0. So go ahead and shift everything 1 unit down, like this. Okay, so believe it or not, we are almost done with this graph. The graph that's going to be the correct answer, I'm going to put in blue. So negative sine of x minus 1 is going to be written in blue. The only other thing that I need to do next is I need to reflect across the x-axis because sine is being multiplied on the outside by a negative. So in order to do that, just think that you're folding your piece of paper across the new midline to get this reflection. So take, for example, this point here at pi over 2, comma 0. If I flip this across the midline, it's going to come down here to, I guess let's label that there. That's going to come down here to pi over 2, comma -2. This point right here is going to come back up to 0, comma 3 pi over 2. So all I'm doing is reflecting these max and min points. There's no need to reflect the midline points because midline points would just stay the same if they were reflected. So let's go ahead and graph this. And so our total graph is going to be the graph that is highlighted in blue here. This is the negative sine of x minus 1. So step 1, we think about it. Step 1, we graph sine of x. Step 2, we shifted it. And step 3, we reflected it. So let's move on to another question. Okay, so for the next graph, just to make sure it fits, we're going to change that -3, change that to -1 just so that it fits. So notice here how this graph is almost the exact same as the last graph, but it's not negative and it has an amplitude of 3. So first things we're going to write down is amplitude, and we know it has a vertical shift of down 1. So we're going to say we have a vertical shift down 1 and we have an amplitude. And we know the amplitude is 3 because 3 is out front of sine of x. So let's go ahead and graph this one in red. Okay, so notice here how we subtracted 1, and so we need to make sure that our midline is no longer the x-axis, but make sure the midline is at -1, which is great because we already have that infrastructure from the last question. After that, we're going to graph sine of x using our new midline, but we're going to make sure the amplitude this time is 3. Which means sine always starts at the origin, and the origin now is going to be at the midline, not at the actual origin. From there, the pattern of sine is that sine goes over one quadrant up to a maximum. But notice how we only went up 1 here, right? So this is a distance of 1. We need to go up a distance of 3. So we need to go up 1, 2, 3 to get the full height of this sine function. So notice we're going up a whole distance of 3 this time. Okay, from there, at the next quadrant line, we should come down to the midline. This is not going to quite fit, so we are going to assume we went down 3, which means we'd go down -2, -3, -4, somewhere down there. Doesn't quite fit. And then come back up to the midline. Okay, so I know this does not quite fit, but we should get a graph that looks something like this. So it's the same as the sine graph. It got shifted down 1. And now you can notice that everything has an amplitude, or the distance from the midline to a max. We can see that that distance is now 3, which works for us. So let's move on to the last question. Okay, so for this last question, I'm just looking. You're not going to have room to quite graph it. So what I'd like you to do is there is a blank page that's on the end of the first section. You're going to see on page, let's see, if we go to the end of the first section from yesterday, there's a blank page. Go ahead and draw a grid there so we can establish this new graph. So what we're going to start with is that. So let's start with a blank page. Okay, so on your blank page, what we are going to draw is a grid. Okay, on the grid, we're not going to quite label anything. Let's just put some dashes. Okay, so now we're ready to start our problem. All right, so what we have here is sine of 2 pi x over 3 plus 3. I'm going to change this once again to make it easier to graph. I'm going to change it to +1 just to make things easier. So the first thing we know is that we have a vertical shift of up 1, but we can also see the b value is different, and so we need to calculate what the new period would be. Our new period is going to be equal to, well, period's always equal to 2 pi over b, but b is this entire huge thing, which is 2 pi over 3. If you keep it, switch it, flip it, you're going to get 2 pi times 3 over 2 pi, and you'll notice that everything cancels, and you're just left with 3. Okay, so that's one thing that we know. So let's take that to the next page. Okay, so right off the bat, we know that our period is going to be equal to 3. Which means that our quadrant is going to be equal to 3 divided by 4, which means maybe we should change the way that we split up our numbering before we label this. So think if our quadrant's going to be 3 over 4, I'm just going to go in increments of 3 over 4. So let's assume that this is 3 over 4. Notice how there's no more pi anymore. So we have 3 over 4, or I guess we could write 0.75. Maybe that will be easier. We're going to say 0.75. Followed by, okay, the next dash would be 2 of those, which is 1.5, and follow this pattern. Okay, so we should get a grid that looks like this. All right, so the next thing that I want to focus on is that we're going to get a brand new midline. We know we're going to get a brand new midline because we're adding 1 to both sides. So let's first start by establishing that we have a brand new midline. Specifically, the brand new midline is going to be now at the line y is equal to 1. So we're bringing the whole midline up. From there, what I want to do is we need to figure out what the sine graph is going to look like. But we know our quadrants now are different. Each quadrant should be 3 over 4. So I'm going to go ahead and plug in some quadrant lines, just some really light lines to remember where each quadrant is at. So our first quadrant is here, our second quadrant is here, etc., etc. So go and mark those out. Okay, so now what's crucial is that we really need to understand how the sine function works. Remember that the sine function is always going to start at the origin, and in this case, the origin is now up at the new midline. From there, the sine function is going to go up. Well, we know that our amplitude is technically 1. So because our amplitude, which is the number in front of sine, is 1, we only need to go up 1 to a maximum. So if we go up 1 here, that's where our next point will be. From there, sine goes back down to the midline, and then it goes down to a minimum, but in this case, it only needs to go down 1. So it's only going to go down 1, and then come back up to the midline. Do the same for the other side. And this right here is the graph of 1 sine of 2 pi over 3x plus 1. So notice how our new markings have no pi in them at all because it was canceled out when we found the period. Okay, so next thing that I want to focus on is what's called the period shift. It's also known as the phase shift. So if you wanted to, you could write this as the phase shift. If you guys write down these classic definitions for sine and cosine, we're going to see that the phase shift always has to do with the entirety of the middle. Specifically, the phase shift can be found by doing the following. If you set the middle, bx plus c, equal to 0, and solve, the negative c over b is equal to x. And this right here is the phase shift. This right here is the phase shift. The phase shift basically tells you how much am I going to be shifting left and how much am I going to be shifting right? So let's practice a problem about this. Okay, so our first practice type is going to be cosine of x plus pi. We can see right off the bat that the period shift or the phase shift can be found by setting x plus pi equal to 0. And so if we solve this, we get negative pi is equal to x, which means I need to move left pi to graph this cosine function. So let's do that. Okay, in order to do that properly, I want you guys to graph cosine of x like you were doing on a cosine or sine quiz. So do that real quick. All right, so once we have this graphed, all we need to establish is that our new graph needs to be the cosine graph. It's still got the same amplitude, right? We can still see it's 1. It actually still has the same period because B hasn't changed at all. So all we need to do is shift this graph left pi. So let's do that. To shift this graph left pi, I'm going to take its starting point and I'm going to shift it to the left pi, like this. And then I'm going to follow the same pattern. Cosine starts at a maximum, goes down to the midline, down to a minimum, and I'm following kind of like perceived quadrant lines. The quadrant lines are just my marked out lines this time. Come back up to the midline, come back up to a maximum, and fill that out. Okay, so what we should get here is that cosine of x plus pi is this green function, which is really interesting because it looks like cosine of x plus pi is the exact same as if I flipped cosine about the x-axis. And so that's a cool observation we'll talk about later. But this is actually the exact same as negative cosine of regular x, which I think is really cool. All right, let's move on to the next problem. Okay, this next problem should be pretty easy to do because we just established that cosine of x plus pi is graphed. So to graph the negative cosine of x plus pi, that should be really, really easy. We're just going to flip across the x-axis. Our period shift is still the same. It's still left pi, but this time we need to reflect across our midline. So reflect across the midline. So let's do that. If I reflect the green graph across the midline, you're going to see, so let me highlight all of my points that I need to flip. You're going to see that it actually turns into the original cosine graph. So the negative cosine of x plus pi is the exact same thing as just writing cosine of x. And so that's something interesting. So negative cosine of x plus pi, believe it or not, is the same as just graphing regular cosine of x. All right, let's move on to the next problem. Okay, so this time we have 2 cosine of x minus pi over 2. All right, so the first thing I'm going to do is establish the period shift. That's going to be by setting the inside equal to 0. 0 equals x minus pi over 2, and you should get x is equal to pi over 2, which means we need to move right pi over 2. And we also should observe that we have a different amplitude. We also can see that the amplitude should now be 2. So let's graph this. Okay, to start this, notice how our period has not changed at all. So nothing really complicated has happened because cosine of x minus pi over 2, the b value is still 1. So we don't need to worry about changing any of our labeled values. But we do need to move to the right pi over 2. So what I'm going to do is I'm going to take my original starting point of cosine and I'm going to shift it to the right pi over 2. But I also need to do something else. Normally the amplitude is 1, but now the amplitude is 2. So I'm going to take 1 and multiply by 2 to bring my amplitude, my new starting point, now up to 2. So I did that by timesing 2. So 2 times 1 gives me that 2. And then from there, we're going to follow the cosine pattern. Cosine, and thankfully all of our periods are the same. We don't need to change our grid. All right, so cosine starts at a maximum. It will come down to the midline, go down to a minimum, which is now negative 2, not just regular 1, negative 1. Come back up to the midline and follow this pattern. Okay, so our final solution for 2 cosine of x minus pi over 2 is going to be this blue graph.